Hello, everyone. I think those of you that are on the YouTube channel should be able to hear us. And maybe if you could write us a short message in a chat that we know that you are online and that we are online, and then you can hear us properly, it would help us. We will start in a couple of minutes. And yes, those of you that are on Facebook stream should be able to see us also in a couple of minutes. We, of course, should be able to see your messages in the chat as well. So hopefully you have some prepared. And yeah, it would help us if you will write us in the chat. Thanks. We have a lot prepared for you today, and we will start in a couple of minutes. Čo si to tam všetko popísal, prosím ťa? Čo? Aha. Hello, hello, hello. Well, due to some unexpected technical issues, those that are waiting on Facebook probably won't be able to join us for this stream. But no worries. We are also recording the session, so we will then post it. And those of you that were expecting it on Facebook will be able to get their hands on the video, and they can learn also something. If you are joining us from the Facebook event, because I posted there that you should join here on YouTube, sorry for the inconvenience caused. Today here with me, we will start now. Today here with me is Juraj, and as mentioned in the two teasers that we posted, he is a professional. He's been with the company for way more than me, and he's really experienced. You can see him right here. And I think that without any further ado, we can jump into what we have prepared for you. We will try to do this in 1 hour, 1 hour and a half. We have prepared a lot of things, so we will certainly try to fit the whole stream into this time. If you will have any questions, of course, we have a chat available in YouTube, so you can write your questions. We will be more than happy to answer those questions as soon as we will be able to. And with that being said, yes. Also, if you would like to, or you are starting your project and you would need, or you would like some help, we offer a free consultation on our webpage, and you can anytime schedule a free Zoom call, and we'll be able to help you, I'm very sure, with your project. Juraj, we have some presentation prepared, and I will turn it on, and I think you can start. And maybe one more thing. Thank you, Gaston, that you wrote that you can hear us. If there is any issue with the sound anytime during the stream, let us know in the chat. Thank you.
Okay, Michael, so please turn on the presentation on my monitor. Yeah. So in this session, we are going to talk about installations, something about preparation, what to care about, and we should go through several steps, topics. Mainly we will talk about just a little bit what are the LED strips, what are types of LED pixels or lighting, what you have to be care about during preparation and installation. Also, we will do very little of soldering and some troubleshooting. So at the beginning, I would like to tell you that we will mainly use term LED strip, but it also apply to pixels. So we have several examples. Yep. So as you can see, we have plenty of LED strips and not so much pixels right now. And that's why we normally say LED strip, but it's also applied to pixels. So as you probably know, you have LED strips which are digital. We call them digital. It is individually addressable LED strips, like these ones. They are usually 5 volt or 12 volt. Then you have some very simple white LED strips, and there are several options, like some of them are self-adhesive, some of them are in silicon tube, some of them are pure white, some of them are RGB, some of them are RGBW, and so on. Also, what we going to talk in this session will also apply to pixels like this one. Yep. So not only the LED strips. What is quite important to tell you is that we mainly use the addressable or digital LED strips with separate control of every pixel. So every pixel can be individually controlled, but also exist some LED strips which has more LEDs per pixel, like this one. So let's say in this case, this LED strip, if you can see it, it's 3 LED diodes, but they are all doing the same effect. So these 3 LEDs are 1 pixel. So if we say LED, we normally mean 1 pixel. But in some cases, more LEDs means 1 pixel. So that's quick show of some products which we're going to talk about. Okay, as you probably know, for LED strips, you need some power source or power supply. Also, several variants exist, like this, for example, or there are some special called LED power supplies, but there is no such a big difference. They just provide constant voltage. Okay, they exist in several power ratings. Let's say this one is 150. In reality, it is a little bit less. We will talk about it right now. So it is very good to know. Okay, it's very good to know that the power is calculated. Power equals to voltage multiplied by current. So let's say we have 5 volt power supply, like this one. Oh no, this one is 24. But let's say you have 5 volt power supply with 20 ampere power rating, current rating, and it equals to 100 watts. So with this formula, you can very easily calculate if you have a power rating of your pixel or LED strip in watt per pixel or watt per meter. Using this formula, you can very easily calculate it. So let's say if I have a pixel and manufacturer provide information, it is 0.5 watt per pixel, and we know it is 12 volt power supply voltage, and we don't know how many current, how many ampere it is, so we can easily divide 0.5 divided by 12. I need to use calculator. And using this, my phone wants to update every day. So 0.5 divided by 12, it equals to 0.041 ampere. It may looks like not a huge number, but if you imagine if you have 1000 pixels, then it is 41 ampere. So even if it's LED, it can consume a lot of power if you use a long runs with LED strips or so many pixels. So this is very simple formula which you should keep in mind always. Okay, so in every installation, it is very good to do some planning. We have some experience if you just come to place with some power supplies and LED strips and you have no drawings and nothing, then it is very hard to start and it takes time. So we recommend you to always plan your installation as much as possible. It many times required to do some testing at home or in your company to know how many meters can be powered from one power supply. We also suggest you to double check the power rating. Sometimes happen that the pixel rating is 0.5 watt, but in reality it is a little bit more, and then you can have serious trouble. So even the datasheet exists, we always recommend you to double check let's say the voltage and so on. Of course, if you are using the RGB pixel, which is the most case, you have to turn it on full white, RGB in total, then the consumption is the highest, and check if your power supply can handle the pixel count which you want to run. Okay, so what we have next? Voltage drop. This is not very nice thing, the voltage drop. And what's happened in voltage drop? Okay, back. Sa to myši robí toto? Nová strana, back.
Nová strana iba swipe.
Aha, takto. Okay. So in case of voltage drop, the situation is following. You have a power supply. You have this is the AC side, AC line, let's say. And if you have the LED strip, let's say, this is LED strip, not very nice, but it is LED strip. And let's say we have 12-volt power supply. These LEDs take some power. Let's say it is, I don't know, let's say 3 amperes. 3 amperes. But on the end, the voltage will be less than 12 volt. Usually it can be, I don't know, 10 volt or so. So if you are measuring and checking your LED strips or pixels, it is very important to check how many LEDs or how many meters you can connect from one side of power supply when the last LEDs are still shining good enough. There is no voltage drop. And also very important is to check if the beginning of the strip is not overheated, because as the current flows, the current is highest at this point and slowly decrease. Okay, so the current density in the strip is highest on the beginning, and that's where the LED strip can go warmer than on the end. And sometimes if you overload it, the last pixels can be still looking good, but the beginning of the strip can overheat and cause problem later, because as you probably know, the LED is not very like high temperatures. Okay, so you can jump to next slide. The power injection solutions. Let's say you have, in your case, you have power supply. You can maybe delete this. You have your power supply, and you have your LED strip, which is very long with many LEDs like this, and you need to provide enough power for each LED, and this is normally done by a parallel connection. So you have two extra wires coming together with your LED strip, and you make the power injection points like this. So this is plus, this is plus, so you make power injections like this. The cable has to be thick enough to handle all the current. We are not going too much deep about how to calculate the wires. If you are interested, we can talk about it much deeper in some next lesson, let's say. So using this technique, you can inject more power. However, if the total power of LED strip needed is more than power supply compatibility, let's say in this case this power supply is 200 watt and this LED strip consumption is 150 watt, you are good to go. But what to do in case if this is not 150 but 300 watt? This is very common case because you normally use a lot of meters of LED strip or too many pixels, so you need to deal with this situation. Of course, you can use more powerful power supply, let's say 300, 400 watt or so, but the problem is that the big power supplies are usually big, quite big, and also they are normally with the fine, so they make a noise. And that's unwanted in, let's say, in television studios or some quiet places where you don't want to make any extra noise. So in this case, you can use more power supplies. And the typical connection is you have power supply 1, PS1 connected to AC line, and then this is your long LED strip with many pixels, and you have power supply 2. But in this case, if you do the back wiring like this with power injection points, like this, at some point you reach the maximum power of your power supply. Let's say this is 200 watt, so it is recommended not going on exactly on the edge. So you will find some place where you will calculate how many LEDs it is, let's say 180 watts or a little bit less than 200. Let's say it is in this point. And in this point, you can start with new power supply, like this. But if you do it like this, you can see that this power supply and this power supply are connected in parallel. Parallel connection of constant voltage power supplies is not very recommended, mainly because of the voltage difference. So if the power supply 1 has a lower voltage, just a little bit, than power supply 2, then the second power supply will push more power into your LED strip, can overload and switch off and such a things. And also by parallel connection of power supplies, you have a problem that your current, possible current, increase significantly, and with today's power supply with 50 amperes or so, you have suddenly a lot of available current. So in case of some short circuit, let's say you bend the cable somewhere or anything goes wrong, then the short circuit current is extremely huge and can overheat the LED strip, can start burning and so on. So in case you want to use or you need to use more power supplies, the solution is following. Okay. So the tiled scheme looks like this. You have a power supply. You have your LED strip. You have to cut the LED strip like this. And this is a plus, this is minus, and this is a data, let's say. So to prevent parallel connection of power supplies, you need to cut the LED strip. So this needs to be physically cut. And the second power supply needs to be connected just to the second LED strip. So it looks like this. Okay, this is plus minus. Okay, of course, still you can use the back power supply to more points. And what is important now? You have a data output and you have a data input. So you have to connect the data in case of digital or addressable LED strips. And it is very, very important to connect also the ground. Okay, so always you have to connect data and ground when you need to extend the data. So this is very, very important connection. Okay, so this keep in mind. Always connect ground when you are routing the data. And as you can see, the plus is not connected between the LED strips. So in this case, the power supply 1 only power up the first part, and the second power supply only power second part of your LED strip. So this is how to connect more power supplies onto one strip. You need to cut the plus. In case, I'm not sure if you can see me. In case you are using the pixels like this, it is much easier. You just cut the plus wire and bring the new power to pixel next to last pixel from first power supply. So I hope this is clear. So this is brief about power injection. As I told on the beginning, it is a little bit tricky to determine what is the maximum length of LED strip or maximum pixel count, as it always depends on the consumption, on the resistance of your LED strip. So there is nothing like general rule of thumbs, because if you have a LED strip which is low copper weight, it has higher resistance and the total length can be shorter. So you need to bring the power injection to more places like this. Okay, so this is always subject to test. If you are getting the LED strips from us, we can provide you the information where to start. Of course, all depends on how long is the input cable and so on. So this is a little bit about power. We can jump to signal connection. This is for me, it is very easy task to handle the data connection, but some people do mistakes or they are unsure how to connect data properly. So we will going to talk a little bit about the connection of the signal. So we have some controller. Usually the digital strips are also called SPI, so I will write SPI controller. An SPI controller has ground output and data output, like this. Some of the controllers also provide the power, but for now, just talk only about the data and ground and your LED strip. This is your LED strip, or also pixels. And let's say you have a ground connection here, you have data connection here, and plus. It is very, very important when you go from your controller to your LED strip to connect not only the data, but connect also the ground. And from the power supply, you have a power supply plus minus. This is AC side. You also need to connect ground to this point and plus to your LED strip. Okay, what in case you have a controller which has built-in power supply, or you pass the power through the controller? This will be the next slide. So let's say I have a power supply, I have a controller, and I have my LED strip down here, let's say. So if the power goes through the controller, plus data and ground, this is very simple. You just have to connect ground to ground, data to data, and plus to plus. So this is very simple. What in case you want to use another power supply for another strip, which you need to connect to another power supply? So if you have another power supply, the same rule apply from the slide before. Okay, so we will do exactly the same things like here. So if we have second power supply, we need to connect ground to ground, plus to plus, and connect the ground and data, ground and data from previous LED strip. So in this way, you can connect as many LED strips as you need. Of course, you need to keep in mind the controller maximum pixel count. So this is a little bit about connection of your LED strip. So this is all about the digital or individually addressable LED strips with analog LED strips which are constant voltage. We will discuss in another video if you will like this one. So right now we are just talking about these digital schemes. Okay. So what is important when you are choosing your LED strips or pixels?
Maybe we can.
Yeah.
I'll show you. So I think that Juraj covered a lot in this couple of minutes, And we have one question. So maybe we can answer that question first. And we can then jump into the next part of the presentation. So, Ashley, I want to thank you for your question, which is very interesting, and I'm sure that Yura can answer it. So Ashley is asking, when using a Symmetrizer, can we use an RS485 isolator to avoid ground connections and possible ground loops? Wait a second, Yura. So we got the question, right? You understood? Perfect.
Yep. So you jump right deep into the data connection. Basically, the answer is yes, because if you use the Symmetrizer, it makes differential signal. So if you have an isolator which is capable to isolate RS485 signals, it also should work well with the Symmetrizer. Just check if your isolator is able to handle frequency. If you are using the most typical SPI LED strips, if it is capable to handle up at least 800 kilohertz or 1 megahertz, it's minimum which needs to be handled by your isolator. So just check the isolator. If you have a exact type which you plan to use, you can send us and we can check it for you if you are not sure. But this was very good question. Right about one of our product, and it is the Symmetrizer, which is used in case you need the long cable between your controller and your LED strip. So in this situation, I will try to be quick as possible. You have controller. I will just mention only about ground and data in this case. This signal is a digital signal, also called SPI, and this is a digital signal with frequency roughly around 800 kilohertz. So it is quite high frequency, which should not be run over very long cable. So if your LED strip is far away, let's say this distance is roughly more than 10 meters or so, you may have issues with your signal integrity. It means the signal on the end is disrupted, or there is some noise and impedance mismatch, so the signal is not good enough to provide good signal for a LED. In this case, you can use the Symmetrizer, which has to be added on your line. So you have data and ground. This is your controller, and you connect the Symmetrizer board. Which output is ground, A and B. And in this case, the signal is differential. So the A is like this and B is opposite. This is called differential signaling. This is differential signal. And the previous situation, this is common mode signal. So if you need long signal runs from your controller or from strip to strip, you can use the Symmetrizer. But of course, on the LED strip, you need to make common mode signal from differential signal, and again you need the Symmetrizer. in another mode, which provide for you the common mode data. And in this case, this length can be roughly 100 meter or even more. We tested about 300 meters, it normally work. But it's very important to use a twisted cable if you want to use long runs. So this is just something about the long runs between the controller and LED strip, or between LED strip and LED strip. You can check the Symmetrizer on our webpage if you are interested. And this question was if some kind of isolator can be added here. Isolator. Okay, so this is some kind of isolator to isolate the ground, to separate the ground of the power of signal source and LED strip. So the answer is it should work well, as this differential signal is similar. Differential signal is similar to RS485 standard. Okay, may I continue, Michael? Ask more if it's interesting.
Okay, so that definitely answered the question to me if I would understand it. But I do hope, I do hope that Ashley, who actually asked the question, get the answer that she was looking for. And if not, then the chat is still available, and you can write further notes that you may have on the question, or maybe we can answer those later on in the presentation if you will have some, of course. So I think that this covered a large portion of the presentation, where we were basically talking about the, well, not issues, but stuff that may happen with your project and that you need to resolve. We have some more tips on how you can resolve these. But maybe, Juraj, we can jump back a bit.
Yes, we can jump back. You just told me on this monitor, I will see the presentation, and I can't see the presentation. So that's why I jump where my mind jump.
Let's try this.
Let's try.
So, or maybe we will show you this first. Juraj, as I told you, was talking about the stuff that might happen during your project. We have prepared a small project of our own, and you can see the project right here in this very photo. Although it might not look as the best representation of a living room, it is a living room. You can see here that we have some, or imagine a living room where you want to put LED strips around the perimeter to your ceiling. So you will decide on your strip, you will decide what power supply you need and stuff like that. You are prepared to put it up, and you will, of course, meet some issues. Some issues will arise. And how to solve those issues, and also how to start with such a project, we will show you right now. Juraj has already put on the table our representation of a living room, which is a box, basically. But with a bit of an imagination, you get the idea.
Yeah. So this is our model of living room, which we want to illuminate on the ceiling edges. We choose it to be able to do it quick enough to not get you very bored. And what we will do now, we will install the LED strip on the sides, and of course the living room is probably a little bit bigger, so we choose the larger side will be 5 meter long, and the smaller side of your room will be 2.5 meter. So in total we will have 15 meter of LED strip, and we will demonstrate also the power issues, the voltage drop on the LED strip. So you will see how the issue looks like, how to prevent it. So you will see it physically, hopefully, if everything goes good. So I will start with this LED strips. This is 5 meter long, as I told you, and this LED strip has nice feature. They start with signal and power connector, and they also provide these cables for power. So we will very easily connect it and see how it works and why it not work and so on. So maybe Michael can talk a little bit till I will do it. Of course, if you are working with digital or you are new to digital LED strips, always keep in mind there is some arrow which point which data direction you know what I want to say. The LED strip has a direction arrow, and you have to connect the data from your controller to the beginning and follow the arrow all the way around your room. So I start like this. I can tell you that this LED strip is RGB, digital LED strip. It's 12 volt type, and thanks it is 12 volt, it has not so significant voltage drop than 5 volt version LED strips. So I will throw this part here to represent we use all 5 meters. Okay. I hope it will be so quick also on the event installation like this. So right now we have a 5 meter strip which start here, and then it is thrown here and continue, and this is the end of 5 meters. So this is the first 5 meter. We can technically turn it on and see if it is working. Even we want to continue with more meters. So, not sure if you can, no, you can't see it, but I have a 12 volt power supply. We'll show you. It's 200 watt power supply, and I have multiple outputs ready. I have 4 wires, so we will connect it later on each corner of our living room. So it's a little bit messy, but I not mean the football player. Okay, so this is the power. It is very important if you are doing connections to have your power supply off and also your controller off, because you can damage something. So now my power supply is off. I will use this little guy. This is a reactive controller, and this will provide me only the data and ground. Maybe you can see there are 3 wires, but this LEDs has a backup. We can talk it a little bit. We can talk about the backup feature later, if you like. So my data should be should be running when I run the Reactivo app. Yep, so let's connect the power supply. Okay, so you can see this is a test mode of RGB. Wait a second, player. Stop test. Settings. Stop testing. Okay, so what's happening now? I have in my Reactivo app chosen the white color as a effect. So right now you have a white color on all your strip, and you can probably see it's working quite good. You can see the beginning is nice white, and I can use the voltage meter just to prevent, just to check what's the voltage on the output. So at the beginning I have 12 volt because it is 12 volt power supply and the cable is not very long, and on the end I can read 8.8 volt, and it means I have a quite significant voltage drop from 12 to 8.8 volt, but the LED strip has enough power to be fully white. So I will continue with the 2.5 meter section. For this I will cut the LED strip. I have a 5 meter LED strip. I will move it to the side like this. Let's see what I damage. So this is a new row of 5 meter LED strip, and I will cut it into the half, and I will talk a little bit about how to cut, where to cut, and what to be careful. So as this is 5 meter, it is not very hard to find the middle of the LED strip. And here it is. This is a middle of 5 meters, so this is a 2.5 if I cut it. You probably know the LED strip is made from half meter pieces. So you can notice on LED strip, usually every half meter you have soldered joint.
Maybe you're right, we can show that in a bit more detail.
Yep.
And
yep.
mm-hmm.
Yep. So this is the soldered point, and it is not obvious because it is 5 times half meter. It is 2.5 meter, and here is the soldered point. We not recommend you to cut the strip in the solder point. We recommend you to cut the strip only in the designators area without the solder. So what to do in this case? I can cut it a little bit offset, like 1 pixel, but then it will be not exactly 2.5 meter. So I will cut it in this area using the soldering station. So I will desolder it. The point why I'm doing it is if you cut it, the some of the part remain on the previous segment, maybe some part is on the next segment. It is not very good idea to cut LED strip on the solder point. So I will do little opening and unsolder it, just like this.
If you can, Uri, show it a bit further in. Great.
Sorry, man. Understand. So, as you can see, I open it. So, I open the tube. So now I have physical access to the solder joints, and it's not very hard to unsolder it if you have soldering iron. So this is also a tip for you. Do not cut the LED strip on solder point, rather unsolder it using the soldering station. So now I will put the connectors, because we will need to use connectors on our edges, because normally on the edges where the LED strip is not bending like this bending is not possible because you will damage the LED strip. So I will install the connectors, which I have prepared somewhere. Yep, yeah. So in case of this connector, I need to follow the arrow. So we are using the male on the input and female on the output. So as this is input to the strip, I will need the male connector. This is the male connector, and I will solder it here. I will show you a little trick. If you are using the silicone tube LED strip and you need axis, you can easily pull the sleeve a little bit, and it jumps off. And now you need to secure it to be still outside of the tube like this. And now I have perfect access for soldering. Okay. I'm soldering first time, so I'm a little bit afraid.
You're doing quite good, if I may say so.
Thank you. I hope it will not be smoke machine like yours.
No, it won't. But while you are soldering, I wanted to ask if there is some tip or trick in regards to what solder to use, maybe. I know that we talked a bit.
Yeah, when you do the soldering, is very important to have some skills. So if you are doing it first time, I recommend you to try it first on some small piece which will be not used in your installation, just for training. And it's good to have a good soldering station and solder wire with the flux, which is very important. And then if you have just a little bit of skills, I sure you are able to solder the wires nice. So we can show you, it's probably it. Okay. So this is 2.5 meter. Michael, you have very small table.
And I thought before, that the table is huge. I always thought that, but it seems that it's quite small.
So I again move the tube to side for easy access to my solder points. As we humans normally have only 2 hands or less, I will use some extra load to keep on place. Yep. Like this. Okay. So, and also good tip on soldering is first prepare the wires and the strip you will solder. I mean, apply some solder to wire, apply some solder to LED strip, and then it is ready for a quick and nice job. Michael, what do you think? It's good enough for first time soldering?
I think you're doing quite good for first time soldering, but while you're doing it, is there something else that you can use to connect the two strips? Some other type of joint except soldering?
Yeah, I know there exist some quick lock connectors with the spring loaded pins, which will like take the strip between two clips, but we have no good experience with this because the copper can corrode over time, so due some corrosion, you have bad contact over the time, and you normally don't want to touch your LED strip once you install them. You want to enjoy them. Okay, so my 2.5 meters strips are ready to be installed in our living room. Okay, so let's continue on your small table. Okay. Up. So as I told you, while you are doing connection, it is good practice to turn it off. So I turn it off. Yep. So I take my 2.5 meters LED strip. I connect it in the corner. So now, for now, the power is still unconnected. I'm double checking the arrow is this direction. Okay. Do not fill up our living room completely with LED strips. I will overhang them like this. So I hope you can imagine this is a 5 meter, 2.5 meter. Okay, so as we go, we can turn it on again and see how it works. Ta-da! And we can see it's working. We will check the voltage on the end. Last time on this corner we had 8.8 volt, and let's see what happened. In the corner we have 7.6 volt only now, so it is more than 1 volt less. And on the end, so this is after 7.5 meter roughly, we have 7.2 volts only, but the strip is still working. Let's try out some different colors if it will work fine. So player, colors, red. And Michael, is it visible on the video?
I think so, but the color changed.
Yeah, on the beginning we have pure red color, but on the end we have kind of magenta. That's a little bit weird, but these are 12 volt strip. They work a little bit different compared to 5 volt, and this is because of the voltage drop. Okay, let's continue and connect next 5 meters and see what's happened. So I unplug it again and take my okay. This is Yep. So this is another 5-meter LED strip.
Yuri, I have a question actually.
You?
Yep, me.
I hope you wrote it in the chat.
Not yet. So I wanted to ask, we got a living room or a representation of a living room here. Would you do it like this? I mean, that you will take the strip, you will install it to your ceiling, and then you will take the multimeter and test it? Or would you do it some other way?
That's a good question. Normally, I will not measure it because we know already that this LED strip can be powered from one side when it is up to 5 meters long. So I know in advance that I will need to connect power here on every corner and it will be perfect. So I know it in advance, but if you are not sure, you can go like this, start with small piece, you can do it on your table and check before you go to installation place. So that's why I'm measuring, so you can nicely see that we have a problem, we have a significant voltage drop, and what's the result. Okay, so I think we are ready to plug it to power again. Yep. Okay, so what we can see now, we have nice red on beginning, some weird color, it blinks. Maybe on camera it is not visible, but it's flickering. Something is not good. So what we can do with this, as we talk about the power injection, we will connect the power on this point and this point. So I will take another cable from power supply, this one. Okay, so I told you to turn it off. Always you do connections, but we are professionals, so we don't have to for this video. And you can nicely see as I'm connecting the power, things are going better. So this part is now good, and still I have problem in this part. So I will connect power also on this corner by another cable. So up. And as you can see now, also this part is good. And I will try to finish our living room. So, where is our strip? Yeah, here. This is the last 2.5 meter strip, which I will attach the corner. I'll go outside. Also, if when you are working with LED strips, keep in mind it is a piece of sensitive electronic, okay? So it is not rubber sealing, okay? It is electronics. You cannot bend it too much, so you have to be very careful while handling. I hope you can see I'm doing it with extra care. Okay, you can see on this end I have a connector, but my input connector is busy from controller, so I will just not use it. So let's connect this corner and plug it back again. Bam. Okay, as you can see, I hope you can see it. This is nicely red, and this start to be magenta, and it is also flickering. Maybe on another color you can notice, yeah, the brightness is much lower because the voltage is lower. So I will add one more point in this corner, solve the problem. Again, I'm doing it while it is completely off. Okay. I hope this is minus. Yep. Okay. So we quickly demonstrate you how to connect 15 meters LED strip in living room, how to provide power to multiple points from one power supply, and as you can see, it is working nice. I think I can play some effects. Player. Animation library. Yep. Is it visible? Mm-hmm. Okay. So we successfully made this installation live, and it can last very long, hopefully. Okay, Michael, do we have some new questions maybe which we can discuss now, or we can continue?
I think that for now we can continue because there are no questions in either Facebook, which we successfully started.
Oh, nice.
Yeah, right. Nor on YouTube.
Okay. Okay, I want to show you one little trick which is very useful for more complex installation. And it is measuring the resistance of power supply while it is off. I will demonstrate it. Even it was not planned, but it is very good advice. Okay, so just imagine the case that I made a mistake. Okay, so this LED strip is correctly connected. Red wire is going to plus and black to ground. So what in case I reverse it? So turn on my soldering machine. Hop. Michael, am I online? No.
No.
Not very nice, yeah?
Not really. You are.
I promise I will be very quick.
So it's not very important what you are doing right now. You are just. Okay.
I'm making things.
But I think people can see that you are using the solder iron. So first time.
Okay. So what I did now. Hop. Up. So I reverse the positive and negative from the connector. The data has no nothing to do with this test. But let's say you did a mistake. Okay. So you did a mistake and you turn it on. I will not turn it on because I know there is a short circuit. But how you can recognize you have something wrong in your installation before you turn it on for first time. You take your power supply into your living room. Okay, it is important. It has to be in your living room. You take your meter into your living room like this, and you connect the leads from your multimeter to plus and minus while it is off. It is important. It has to be off. We are going to turn it on for first time. I select the resistance measurement, and I will check resistance between plus and minus. And I can clearly see there is a short circuit. There is reading 0.5 ohm. Okay, this means I have a short circuit in my setup, and I shouldn't turn it on, something can burn or goes wrong. So, as we all know, the problem is here. I will fix it quickly. Okay. Okay, I hope I'm not too slow. Okay, so I fix the problem. Now the red is positive again. So I will plug it back and make the new measurement. And between plus and minus, I can read 57 ohm in this case, which is much higher than 0.5. So it is a good sign and it can be turned off on. Okay, so this is the practice we normally do. Once we connect everything before first power on, we check the resistance between plus and minus on every single power supply in our installation. And by doing so, you are kind of sure you have no such a mistake on your installation. It not means everything will be perfectly fine, but you can solve the problem or find the problem before you turn it on and damage on or burn something. Michael, I hope you know it, because last time your strips started smoking.
You think that this was the issue?
I'm not sure, but I not check it, you not check it, and that's what happened. Okay, so I hope everything is clear with this nice living room, and I can pack it up for now. What do you think, Michael?
I'm just checking that. I'm just Slovaking. I hope that someone knows how we are actually playing against Kazakhstan. But we can, if there is someone in the chat who is actually watching the match. For those of you that don't know what I'm talking about, we are playing a hockey match against Kazakhstan today. And we of course have no idea what is the current score. And what I am also checking is the presentation that we have prepared. And because since we finished with the living room and we probably showed every last issue that can occur, correct me if I'm wrong, but we do have talked about the power injection points. Maybe we wanted to show also, because the controller that we are using and the strips that we are using are not compatible. Is that the right expression?
Yes, you are right. They are compatible.
Well, yeah.
SPI signal, but wait a second, I will clean this mess. Okay, so we are using this little device, which is called Reactivo, and this device is only 5 volt, and our LED strips were 12 volt. So we only use ground and data from the controller, and we use separate power supply. That's the situation which we described. Press some button to continue. Opa. Up. No. Yeah, that was exactly the case. Yeah, so we had the power from power supply and we had the signal from controller, in this case from Reactivo. Okay. What time we have? Michael, what do you think about the small break? Small break. Short break. Short.
Short, like 5-minute break would be.
Yeah, 5 minutes.
Would be okay, I think. Uh, in the meantime, you still are uh, able, free to ask any questions. So if you have some, feel free to write them in a YouTube chat or on Facebook as well. After the break, which will take 5 minutes, we will show you some gadgets that we have. Those gadgets you can use in troubleshooting some of the issues that might occur in your project, like when you want to use a long strip or long connection from the controller to the strip, and or if you want to use a long cable not between two strips in general. Yurai talked about these things before, but we can also show you how they actually look, and he can again tell you how those works. And then we can also jump back a bit and talk about some strip types if you will be interested, and we will see. Hopefully, we will receive some questions. I do hope that you can hear me properly now, but I did raise the volume, and I was also checking, and Yura was loud and clear, so this part was okay. Great. 5 minute break. We will just turn off the sound, and we'll be back.
Ja som si to tak inteligentne. A asi dobre.
Yep. So I think so, yeah. I think that 5 minutes is already over. So we can jump back in. Yeah?
Okay.
Would you need a tablet?
Maybe. Yeah.
We will start with tablet, yeah? And we will as mentioned, we will show some gadgets that we have that might help you with your projects. So
Okay. I would like to show you one situation where you need to extend the data from LED strip to another one with a longer cable and some issues which may happen. So, people tablet. Okay, so I will jump like this. Ide tablet? A ja furt neviem, čo ide. Okay, so you have a situation where you have LED strip and you need some long cable to another strip. Right now I will not consider the voltage drop because let's say it is short piece or you have power supply nearby. Let's say I have power supply here and I have power supply here. So I'm not having any power problems or voltage drop. Thing is I need to connect a long cable with SPI signal. We talk today about the Symmetrizer, which is a converter from common mode to differential mode and back. But when the distance is not very long, let's say like 10 meter or 15 meters or so, you can switch the camera. So I made a simple setup. I have my controller. I'm feeding power from power supply and you can see everything is working. I have piece of LED strip. The length is not important. It's 1.5 meter and 1 meter. And as you can see, it's working perfectly fine. But what happened if I add like 2 meter cable? So I'm adding 2 meter cable and you can see it worked perfectly fine. What in case I add next 6 meters? So in this situation we have 8 meter cable. We have 8 meter cable from one strip to another and you can see this one is on. Some weird things happened. Something is flashing. Simply it's not working. Why this happened and how to avoid it? The LEDs has a data output and it has some impedance and drive strength. And in this case, the drive strength is very small. It is on one side, it is good for EMI related problems, but in this case, the capacitance of the cable increases and the signal is very weak on the end. So we have some buffer. This is a simple common mode buffer. We have two versions. This one is with screw terminal. We have one very small. And I simply connect the buffer on the end of the strip. and to our long cable, and now you can see it is working perfectly fine. Why is this? It is because the last LED output has very weak drive strength, and the cable has some capacity, and the signal drop to some level, and the first LED on next strip just don't understand this signal. So this buffer has very good drive strength. It can drive like 10-meter cables. So this is the helper. If the device is too big for your usage, as we mentioned, we have this small buffer which can be soldered directly on the LED strip. I will demonstrate it on this little piece where we solder connector for input and output. As you can see, without the buffer it is not working, and with this buffer it should work. Yep. So this is kind of little help, but sometimes this can save you a lot of time to find the problem or to solve the situation where your cable is long and needs to be long, and you have no more outputs from your controller, so there is no other chance how to solve it. So this guy can help you. But keep in mind, this is not like for 100-meter cable. Okay. So Michael told me that we have some new questions, so maybe we can try to answer them now.
Yes.
Yes?
Yes.
You sound a little unsure.
Now, we have the question, but I have to, of course, locate it. I will show it actually to all of us. And this question was a bit lost, but we found it. It was on a Facebook. So thank you to those that are watching the stream there. Yuri, are you able to see the question?
Yes. My LEDs are getting heating while making glow LEDs with white color. I have problem with my LED, or the need a long wire power supply. Okay, if your LEDs are too hot, there are two possible reasons, or at least two. One is the LED is not designed for the PCB it is mounted, or you have so many LEDs. And in other words, you have simply so much power density by LEDs on small place, and then it becomes heated. Or another thing can be you have huge current in your LED strip, so the most of the heat not come from the LED but from the current flowing. So if you add the parallel wires, the power injection wires, you can bypass the current through the wires, not through the LED strip, and using this technique you save a little bit on the heat. Another possible solution is to decrease the brightness. If you are using our controllers, we have in controllers feature called maximum brightness, and if you set it, then the maximum power is limited. So you can see this LED strip now, and if I go to settings, which you not see, but in settings I have an option called global brightness, and I simply can reduce the global brightness. Sure, the brightness is lower, but also there is much less heat than before. So this is kind of a bypass of your problem, maybe. Hopefully it helps. Do you have another question, Michael?
Not from the viewers. Actually, I'm just checking the YouTube stream and Facebook, and it seems there are no more questions.
Okay, till you will check what's next. I think we will be very thankful if you leave some comments for this live stream, what you like and what you don't like. So if you have not only the question but some comments, we will be glad to read them. Michael, so do we have some next topic which I forgotten?
I just think that we covered the. We showed the audience that we have this small buffer that you can use when you want to connect strip to strip. We talked about the Symmetrizer. Did we actually show the Symmetrizer? Do we have a Symmetrizer somewhere? It should be there in the shelf, but if not, I happen to have one with a cable and with Ethernet cable. I'll give it to you.
Type is here. Maybe it's good to explain you what's the difference between differential signaling and common mode, and what's the difference between using the buffer and the Symmetrizer, and yep, what's this? Okay. The main difference is the buffer is just amplifying the signal. It provides a little bit higher current and lower impedance for the signal, and therefore it not drop so quickly. But it is usable only for the short distances, like 10 meters or something like this. There are some disadvantages, and mainly it can make some more EMI noise, and it is not so immune to noise compared to differential signal. But disadvantage of differential signaling is that you need two devices, one on the signal start, another on the signal end. So one will make the differential signal from common mode signal, and another one will receive the differential signal and make the common mode. So you need two devices instead of one. And another disadvantage of differential signal, you need two wires and plus ground. Ground is really recommended. So you need one more wire for the negative output. So that's the main difference. The Symmetrizer we have also in this shape. This is ready for RJ45 connector. So if you need a long cable run from, let's say, from this strip to another one which is 100 meters away, you can simply connect this wire to this terminal block, and you will get the differential signal on RJ45, and then you can use very cheap Ethernet cable. Can be 100, 200, 300 meter long, and another device on the end. So it can be boxed and it looks like this. So this is about the differential signal versus common mode. Okay. And the big advantage of differential signaling is it is very immune to the noise. So if you have a lot of cables, let's say in structural cabling in the buildings, and in the TV studio you have some motors and stuff like that, so you have a lot of cables in one conduit, and there is high EMI noise, then the differential signal is a choice, because it's much more immune to noise than simple common mode signaling. Also we have controller, our controllers, the Spimetrix and LEC3, they have Symmetrizer inside, so they can provide you differential signal just out of the box, so you don't have to use any board. You are getting the A and B signal right from the controller. Michael, any more questions?
No more questions. No more questions from neither YouTube or Facebook. And it seems that we covered almost everything. We covered a lot. I do hope that you will be able to digest it all. Those of you that were watching, this will be also. I mean, the stream will be available on our YouTube, and we will also put the presentation up on Facebook. So if you missed it, thanks to either you being late or us being late, you will be able to check it out. Actually, we have a question now. Thanks, Igors. Igors is asking Spi Lamp, Spi Splitter presentation, if possible. So you would like to check, you would like to hear something from Uri in regards to Spi Lamp and Spi Splitter, if I am correct. We don't have anything prepared in regards to these two gadgets or devices, but we will ask Uri if he's able to give us a short presentation or tell us something about the... Yeah?
Sure, I can try. Okay, so if you can turn my tablet on screen. Okay, so in typical situation, you have a controller. I will just type C as a controller, and you have an SPI output normally. Then you have some cable, and you have LED strip. Let's say you want to hang the LED strip from the ceiling. So I will just mark it like this. Okay, so I have a, it looks like a traffic light, isn't it? So this is the LED strip hanging from the ceiling. There is some kind of hook, let's say. But I want to hang a lot of them, okay, like this. So what I have to do in order to make it work, I will need to connect cable from the end back to the hook and to another one. And then I will need to connect cable back to the hook and to another one, and then again to another one, and so on. What does it mean? It means that I need 2 cables for each lamp. Let's call it lamp. Okay, so we can call it lamp. It not necessarily need to be lamp, it can be any object. But in this case, it's a little bit complicated because always this cable can be long. I mean, you need to make this cable long. So you will need, let's say, to use a buffer. So you will need to use a lot of buffers in order to make it work. So we have a device which is called Spi Lamp or Spi Lamp. And this device works like this. You have a controller. So this is normal case. And this is a SPI lamp case, okay? So again, we have a controller. We have our lamps like this. It not needs to be 3 pixels, okay? It can be like 60 pixels, no problem. So what is SPI lamp and what does it do? It means you have a signal. This is not SPI signal, okay? This is our protocol custom. This is our customized protocol, and we have a SPI lamp. Not very nice. I will just mark R, Spi lamp equal R, okay? R as a receiver. And SPI lamp receives the signal from the controller. It generates the SPI signal, and it has also an output. So this setup look like this. And the huge advantage is that this cable can be long. Okay, this cable can be very long, like long more than 100 meter. And it generates SPI right in the Spi lamp. It means you don't need to go back with wire. And also, if let's say this lamp is broken or it is unplugged or whatever, it not affect the other ones. Okay, so these lamps are still working fine. So this is kind of extension of outputs from the controller. So you have many separate SPI outputs, SPI, and everything what you have to do is to set the pixel count on the SPI lamp. So let's say here are 60 LEDs, 60 pixels. So on the Spi lamp you have a dip switch. You have a dip switch and you need to set the count, pixel count. You set the pixel count on the dip switch and that's it. And you are good to go. So this is little explanation of what SPI lamp is doing and how it can be used. And you can connect a lot of them. I think roughly around 100 maybe. Yep. Yeah, you can see it probably now. This is the device. It uses RJ45 connector for easy connection from one device to another, and its support voltage is from 5 to 24 volts. So it is quite universal for 5 volt strip, 12 volt strips or pixels or 24. So it is about the Spi lamp. Michael, any other questions?
And well, you said that it can connect multiple devices, or you can daisy chain multiple devices. Yeah, so it's like 85 of those you can daisy chain, right?
But the total maximum pixels you are using on one output from controller is limited to 1024 of RGB pixels.
There is also a minimum, no, that you can connect.
9 LEDs, I think, if I remember well, it is, which is the minimum pixel count you can control. Of course, you can connect just 3 pixels, but then you need to count in the mapping you have next 6 which you not use. That's it.
So the other question was, if we covered Igor's, that's a question for you. If we covered this, yeah, great. And also, you asked about SPI splitter, or you meant this SPI lamp? Because you might be talking about some other device that we have. Pixel Shifter. That's also an interesting device. Yeah. Is it okay, you're right, that we will just cover this, and then after we won't answer, we won't receive any other question, then we will.
Yeah, sure, we can go ahead. So another device which is called Spi Shifter or Pixel Shifter? Pixel Shifter.
We call it Pixel Shifter, I think.
Pixel Shifter. Spi Pixel Shifter is one of our device. I will make some kind of schematic. So you have a differential input, and then you have a logic circuit, and then you have a differential output. It means it received the differential data, but differential SPI data. Okay, this is not custom protocol. This is SPI from controller, and this is also SPI but differential. Okay, differential. It means you can use our controllers with built-in Symmetrizer or other devices also. And this logic has it has a 12 single-ended SPI outputs. And what this device do is it receives the SPI data and it shift the pixels. So it means this is RGB 1 pixel, and the next pixel is on RGB on another output. So what is this good for? Let's say you have a kind of a pixel like this one. Okay, so you have just simple RGB pixel like this one. They exist also bigger ones, and the same situation, you want to hang it from your ceiling and you want to have 1 pixel. If you do it like this, you will need to extend the output wire, and again you can face to the signal drop problems. So this SPI pixel shifter can be helpful for you. As you connect 1 pixel to each output, you have 12 outputs available, and this will be output 1, and you don't have to go back because the second output is automatically shifted by logic inside, and you have second pixels. And you can connect plenty of these devices in a daisy chain. I think it is 1024 divided by 12, which is quite a lot. Maybe 70, 80. Yeah, 85. So you can connect 85 devices in one daisy chain, and you can connect 1000 plus pixels to the outputs, and you don't have to go back from every pixel. I hope it answers the question. Maybe you can also show it in the web page. It's how it looks like. It looks much better than my drawing.
Your drawing is pretty okay. I think it looks awesome for for what I can tell. I can't actually show it on our page because this is a device that we have to add onto the page yet. But it's nice of you to mention it.
I have seen video you were playing with the pixel shifter.
Yeah, there are a lot of videos of me playing with LED controllers and stuff around here. But this one I don't have ready, so I can't really show it. But if you are interested in such a device or any other device that we mentioned, you can always write us an email, and we will be more than glad to help you out with any kind of problem and any kind of installation that you might have. This is certainly not the last video or last training that we have in regards to this group of topics, I would say, because before on our previous trainings we were talking about software, and this time we have a professional here, Juraj, talking about the hardware, and it is important, it is interesting. This is certainly, as I said, not the last one. So some other time, if that's okay with you, Juraj.
Yeah. Yeah.
Cool then.
But what I want to also ask you, our viewers, if you have some specific problems, we will be glad to receive them and discuss them with you. Maybe we have an answer for you, or we will find a solution. So if you have any kind of a problem in your installations, maybe we can help you or design maybe new product which will fit your needs.
Nicely put. Nicely put. Yeah, that's what we do, right? We do develop new stuff all the time, and we help out our customers every time they reach to us. Actually, we have another question, Juraj.
Come on.
Is it still okay with you that we will take this question? I think it is. So the question is, I have a LED Pixel. I guess the USC 512 is a strip type. Is it possible? Can it work with your company controller? Thank you for the question. This one is from YouTube. Truth to tell, I can't really answer that, although I would love to. Or do you know the answer, Juraj?
No, because in the market there is a plenty of ICs for the LEDs. A lot of them are compatible. Okay, so you have some WS2811, 2812, TM1804, and so on, and they are all same and compatible. And on our devices, we permanently update the firmware for support with the new ICs. So if the IC you need is not listed, you can ask us. Normally, you send us a sample of the LEDs, and we can add support to our devices. That's normally done. So hope it answers. Oh, I see you are trying to check if the UCS is listed.
Yes. Yes, that's what I'm doing. I'm trying to connect to one of our devices that is actually on the network, and there I am able to see what type of strips are actually supported. So I think that I should be able to show that list to you. And as you can see, the list is pretty long. Right? So there are a lot of strip types that our devices support. And it might be that your particular strip type or IC is not in here. But as Juraj mentioned, they are similar or comparable. So it might be that it will work.
Or maybe we can program it if it is possible. Normally it is possible. A lot of these types you can see on the screen are there because we had a request from our clients if we can add support for this chip or that chip, or if we can try if the chip works. So if you have a chip which is not listed, just book the consultation or send an email, and we will check it for you and try to fit your needs. Also, the controllers are possible to upgrade the firmware once you get them. So as the time goes, later, let's say in 1 year or so, you can get a firmware update for free and update your device, and you can get support for more ICs. So you are not locked to current supported ICs. In the future, you can get support for another ones. Yeah. Yeah.
Sorry, I was trying to simultaneously do something here in the software, like edit, and simultaneously try to answer the question that's on the YouTube chat. And all of you that are there have our info, have our email address there, so you can write us anytime with anything that you will be interested in the future. We'll be more than happy to answer all your questions. And as mentioned, we will be making more such trainings in the future, because Juraj and I really enjoyed it.
And you will make more smoke machines. Maybe.
No more.
No.
No more smoke machines.
Okay, so if it is that all, Michael?
One more.
We had, oh yeah, I can see we have 4,000 online viewers. So thank you all for coming.
Maybe one last question, Juraj. Juraj, one last question.
Yeah,
Yeah?
come on.
I have to go through the question first. Sorry. Let the first heating problem again. Heating problem again with 5-volt strip. So I get it's some IC, pretty typical. So SK6812. I'm not sure if it is a strip type specific problem or not, but you will know the answer. I have 3 wire, which is 5-volt data and ground, but my LED has a heating problem. I think we did we cover this before?
Basically, I just said that there are two possibilities. The main possibility is why the LED strip is overheating. Maybe it's wrong design, or there is too much current in the strip, which is causing the overheating. So it is hard to say. There are LED strips like density of 144 LEDs or pixels per meter, 5-volt, and it produces significant amount of heat, and it is normal because there is a lot of power. So it is recommended to use some aluminum profile to cool it down or to decrease the brightness, and also try to avoid the situation where inside the LED strip is a huge current, like like 10 amperes or so. It's very very high current for such a thin PCB. So that's also causing the heat. Basically, if you are not sure what's causing the heat, let's say you have LED strip like this. This is the beginning of the LED strip, and this is the end of the strip. And if you run the white color, and this part is significantly more warmer than the end, the reason is the high current. So you can check if it is high current, or it is just bad design, or less copper, or not enough heat sink behind the LED strip. So with this density, you normally don't need some special heatsink, but if you are working with higher densities like 90 LEDs per meter or 144 per meter, you definitely should use some kind of a heatsink, or decrease the brightness to some level where the heat is not an issue anymore. Okay.
I think that answered the question. I will just ask you if you have any further questions in regards to this specific issue that you have, to write as an email to that I provided in the chat in YouTube. The session is already 2 minutes and 15. Let's say the 10 minutes in the beginning we started 10 minutes late, so it's 2 hours. We don't want to bother you anymore. We do hope that it was interesting for you. Thank you, Juraj. Thank you all that joined the session. you love that word. Yeah. And this presentation will be available on our Facebook page, along with some other materials with Juraj's drawings. So you can go check it out.
I have to I wanted to cover so much, and then I jumped too much deep into some things, and then maybe I mess it a little bit, but I hope we provide some useful information for you.
Any kind of further questions that you might have, write us an email or contact us, and we'll be more than happy to help. Thank you again for joining. Looking forward to meet you on some next session that Juraj will host in regards to hardware. Thanks, and have a nice evening.
Thank you. Nice evening. Good day. Bye.